Hello, Assalamu alaikum student. In today class, I'm starting A-level electricity topic. A-level physics electricity topic. In today class, I'm starting. This is very important topic and questions coming from this topic in past papers. If you know the topic completely, then you can solve past paper easily. Now, I'm telling you about the electricity here completely. If you know about the electricity completely, then you easily learn uh, or solve the past paper questions. Now, first thing in this chapter in electricity, electric current. Now, what is the electric current? Simply, we say electric current is the flow of the charges in unit time. What is the electric current? Electric current is the flow of the charges uh, in unit time or per unit time. It is known as a electric current. Flow of charges in unit time. Okay, how we define electric current? Flow of the charges in unit time. When charges are flowing, mean moving, flow of charges in unit time. Or per unit time. It is known as the electric current. Every material objects like conductors, okay, current is flowing in conductor object. Every conductor object consisting the charges, positive and negative charges. When we apply the potential difference on the conductor, potential difference on the conductor, work on the charges. When we do work on the charges, now these charges moving towards their respected electrode terminals, towards their respected terminal, just like positive moving the negative. When charges moving, flow of the charges, negative moving towards the positive. When charges moving in a conductor, the flow of charge in unit time is known as the electric current. Okay. Now, what is the formula for electric current? Current we denote by I, then it is equal to Q upon T, mean charges flow per unit time. Now, this is known as a current. Okay, when we write the when we say the flow of charge in unit time, now it is representing the current. Okay, and current is I, and what is the formula for current? No, it is the uh, formula I equal to Q upon T. Q mean the charge and T is the time. Q mean the charge and T is the time. Now flow of unit charge in unit time is known as the current. Secondly, charges and in conductor mostly electron, delocalized electron moving. Now these are delocalized electron moving in a conductor, delocalized electron, which is responsible for the movement of current. Mainly these free electron, delocalized electron, positive atom and delocalized electron, positive atom and these localized electron responsible for electrical conductivity. And the charge value we represent in coulomb. What is the charge value? Charge is Q, and the unit of the charge is coulomb. column we represent by C. Just like if charge is 5 column, it means this is the value of charge. On electron, there is a electron or proton. There is equal charge, and the value of this charge is 1.6 into 10 power 1.6 into 10 power minus 19. Now this is the value of the charge on electron or proton. 1.6 into 10 power uh, minus 19. Now this is the value of charge on electron or proton. It is constant, and basically we represent the charge in column, just like 5 column, 10 column. This is the magnitude of the charge represented. And the formula of current is I equal to Q upon T. Current is the flow of charge in unit time, and Q is equal to the product of current and time. When we form equation for Q, and then Q is equal to current into the time. Now, this is the formula for electrical charge. And the charge uh, is equal to current multiplied by time, and current equal to charge upon time. This is the formula of current. We can say flow of charge in unit time, and here we say the product of the current and time is equal to charge. Charge is the multiple of current and time, and the unit of the charge is coulomb. Now we describe here when the current moving from a conductor, uh, what is the value we can form for the total charges which are present in the conductor. Now, how we determine this value in a conductor? For example, this is a conductor, and the length of this conductor is L. The length of this conductor is, for example, the length is L. Okay. We consider here the length of conductor is L, and charges which are present in the conductor, these are the Q charges, and these are moving and flow of these charges forming the current. Okay, charges Q, which are electron or proton, the electron and the atoms. Now these are moving, and the flow of these charges forming the current. The value of the conductor length is L. Throughout the length, many charges, million charges present. These charges moving in length, and when charges moving in the length, these charges forming the value of current. If we consider the area of the conductor cross-sectional area, this is A. If we consider this is the circular area, okay, from a one cross-section, this is the circular area. When charges moving, the number of charges we consider n. Number of the charge we consider n. Here we are forming the total value of the current, how total charge present and moving, and forming the value of current. Here we describe the current with respect to total charges. Now, number of the charges, we describe these charges by n. Number of charges which are present in the conductor, these are n. And the length of the conductor L, and the area is A, and Q are the charges which are moving in a conductor. And the electron charge value is E. And if we are forming the value for the total charge of the conductor according to formula, it is equal to I equal to Q upon T. Now this is the formula. Now this is the formula for current. We know that flow of charge in unit time is forming the current. If we are forming the total charge, now what is the total charge which are present in the conductor? Now this total charge is the product of the area into number of charge into moving charge V and N to the charge. The total charge we can represent uh, by A and V into Q. In total flow of charges, total current we represent by A and V Q. A is the area of the conductor, N is the total number of the charges, V is the flow of charge, speed of charge, and Q. Now, how we determine this A equal to, in exam, this type of question coming. Change this I into A and VQ. Now, how we form this one? If we are saying the total charges present in the conductor length, it is the product of N area of conductor, number of charges, into area of conductor, into length, mean the charges present in the total volume of the conductor. Okay, when we are forming the total charges, we apply this formula. Number of area multiplied by volume. Number of charges multiplied by the volume. Number of charges and multiplied by the volume mean area of conductor into length of the conductor. And it is multiplied by charge, Q, value of the charge. Now this is representing the total charges which are present in the volume of the conductor. If charges are moving in a conductor, it's mean volume involved. Total charges which are present in the volume of the conductor. And we know that the volume is the area into length. Area into length. If we are forming the total charges, if we are forming the total charges, these total charge, we can now find with the help of formula N volume length. And N, the number of charge, volume is area into length, and Q is the charge. Okay. When we put this value in the current formula, I equal to NALQ in this formula. Now the total charges are NALQ, which are moving in the conductor volume. Now these are the total charges which are moving in the conductor volume. Number of the charges, area, length, Q, number of charge in volume and charge value. Now this represents the total charges. When we divide the total charges, now this is the Q, okay? This is the value of total charges of Q. When we divide this by T, now what is the formula form here? When we divide the Q by T, now here the formula is form I equal to N A Q and L over T. Separate the L over T, okay? Because distance upon time representing the speed. Distance upon time representing the speed. Now, number of charge, area, Q charge, and length upon time representing the speed V. It's mean the total current which is flowing, representing the formula or forming the formula when we solve or drive it, NAQV. V is the speed here, okay? Now, by this way, we can drive. This derivation is coming also in the exam in past paper, okay? How we drive the current formula into NAVQ. In this formula, A is the area, N is the number of charge, V is the speed, and Q is the charges. And what are the total charges? Total charges equal to N, AL, AL mean volume, into charge Q. Total charges are A, N, NAL, mean number of charges multiplied by volume multiplied by Q. Volume we divide into AL. Volume we divide into AL. Now the total charges form NVQ. There is volume, okay? When we divide the volume into AL and we put this formula into I equal to Q upon T, when we put this value in formula I equal to Q upon T, now what is the formula form? I equal to Q upon T. And we know that according to over derivation, Q total charges are the NAVQ. Total charges are the NALQ. What is the value of total charges? NALQ. area into length into charge value Q into number of charges. We can solve this formula for electron and proton also, okay? When we put, but both are same because charge value is same and the number of charges which are present and divide by the area into length and into Q. Area into length is the volume into Q. Now this is representing the total charge Q. When we put this formula value of the Q into a formula Q over T, we get NaLQT Q upon T. Okay. Now we get again NaLQ upon T. It's mean now the formula I equal to Q by T is NaLQ upon T. When we put the total charge value here, now L upon T is the speed. It's mean now formula is formed NaVQ. Now this is the current formula. Now see my videos and comment on my comment site if you want to learn any chapter with me. Inshallah, I will continue this chapter in next videos. And this is the basically electricity chapter. And I am here understanding and try to clear the chapter according to the past paper. Now, these type of question coming in the past paper. How do we form the value of high NAVT? This type of derivation coming in the past paper. Okay, student. See my video, check and subscribe my channel and comment on comment site. I will prepare videos for you. I am online teacher of math, physics, and chemistry and biology of O and A level, IGCSE, GCSE, Edexcel, Parison, and IB board I am teaching. Okay, student? Allah Hafiz.